We're next up, leading into our break, we've got Matt, who's going to give us a brief intro into MicroPython. So if you want to share your screen, Matt, you can take it away.
Right, so tonight I'm talking here about MicroPython, which is something that's probably a little bit different for you guys, because I know there's a lot of people here that do web development. I'm a software engineer that sort of played along the whole range of the stack, all the way from like little itty bitty devices doing assembly through to web development. But a lot of the time I have spent using these little tiny devices. I should say it's tiny devices like this, if you can see that. These are called microcontrollers. I'm sure you all know about them, but it's interesting to think that in a general household you'll have plenty of PCs. You'll have, a typical household has like 3 or 4 PCs, but in terms of microcontrollers, you'll have dozens of them, and that's not including the ones on your phone, which most phones have 20 or 30. So these things are prevalent; they're everywhere. And so I've done a lot of development in that space, in the embedded space, but it really hadn't changed for decades. A lot of it was like embedded C. You have to very carefully write this code. You have to deploy it. It's sort of, you feel like you're working back in the dark ages of software development. And so a few years ago, I got involved in MicroPython. MicroPython gives us, well, I'll get to that in a second, I guess. What is MicroPython? This is what we're going to cover today, a bit of what it is, a bit of the history, why I think it's really cool, and a quick look at some of the hardware we can use, and maybe if I've got time, a couple of the projects that I've worked on. Right, so I'll put these links just up. I'll share these slides out later, but I thought they were here for reference. We're really active GitHub, really active forums and Slack channels. And if you want to reach out to me, I'm there at the bottom. So what is it? It's an implementation of Python 3 for microcontrollers. So what that means is we don't actually share any code with CPython. It's a complete round-up re-implementation based on the language definition. And that's because CPython is not written to work on a constrained environment where you might only have, like some of these devices have 32K of RAM and maybe 150K of flash, right? Not very much, not very many resources. It's written in C, really tight C. And when it was started, it was based on Python 3.4. It's since expanded, and so we've now got some more modern features. Basically, we're adding features as the memory and the flash allows, right? So if we can figure out a memory efficient way to implement a feature, we typically do. So we've got async IO, which is super useful in the embedded space. We've recently got the walrus operator, and we've got f-strings coming now. F-strings are a good example of some of the compromises we have to sometimes make, because it's not a complete f-string implementation, because recursive f-strings can consume a lot of memory, but it's 95% there, and it means that we can use a lot of libraries that want to use things. I'm kind of assuming that people have at least a concept of what Python is. So we have really good support for the Python language. We've got lists, comprehensions, generators, all of that kind of stuff, and this is all running on those little devices. It's actually really similar to the way you would use Python on a big computer. We call it Big Python, right? We also have the standard library, but it's here we start to get a little bit unstuck, because the standard library is vast. There's hundreds and hundreds of modules, and very few of them have been written to consider memory, and so it's very difficult to port them directly. So we have got reasonable coverage of the standard library, all the things you sort of stumble on day to day, but not everything, and so that's an area of development at the moment. And it's a similar story for third-party libraries. Like, we've got to be careful about what kind of libraries we're going to try and get running on these devices. No one's tried to get Django running on it, for example. As well as the standard library and third-party libraries, we've also got something that MicroPython supports, which is the machine module. And this is a library that gives you all of the standard things you would use in the embedded space. So for those that are familiar with that domain, we need ways to turn pins on and off, and we need protocols like SPI and I2C to connect to our peripherals. PWM's a common technique to dim LEDs, right? You turn a pin on and off really quickly and change the duty cycle. So the machine library gives us all of those sort of primitive building blocks that allow us to do stuff in the embedded space. And it's in a Pythonic way too. They're really easy to use. So if you've come from that C background, this is a complete revelation, because doing this stuff is quite difficult in that world. Just a quick example, how we create a pin. If this represents an LED, we allocate a pin to it, we make it an output pin, and we turn it on and off. It's as simple as that. If you want to use PWM, we wrap up that pin, we tell it that we've got a particular frequency that we want to have as our base frequency for PWM, and then we just change the duty cycle. And so this will make our LED go dim or bright. Again, if you're coming from the C space and you've tried to do those things, you've just lost like a day or two. It's really painful. I'll kind of gloss over the history a little bit, but suffice to say that it was started back in 2013. So we're looking at 7 years. It's getting pretty mature now. It was started by a guy named Damien George, who's a Melbourne-born guy. He started this when he was in the UK. But thankfully, when I reached out to him thinking he was in the UK, he said, "Oh, let's meet up next week." And turns out he'd moved back to Melbourne. So Damien's in Melbourne and developing this. And you can see it's been used all over the place. I work for a company that uses MicroPython to make medical devices. So it's quite a legit, serious kind of language. It's also been into space. And so it's being used all over the place now. It's imported to a whole bunch of different architectures and devices. So the key features are that we get to use this high-level, wonderful language in a place where the current dominant language is C. So in and of itself, that just makes development much more friendly and much more painless. The other thing that's really hard to overstate is that you've got a REPL on a device. So much like you would type Python at your regular terminal and interact with the Python interpreter in a live sort of fashion, we can open up a serial connection to a device, and we get the live REPL that's running on the device. This means that we can turn pins on and off, we can interact with peripherals, we can do everything that you could normally do at a Python prompt, as well as do all that embedded stuff live and interactively. And that's a complete revelation. That's really difficult to do with the C sort of compile, deploy, try out sort of cycle. So yeah, it's always fun getting an embedded engineer and showing him the REPL, because that kind of blows their mind. Running peripheral drivers is really a lot easier as well. Again, you can use the REPL to do it interactively, but you've also got the power of Python. So you can use regular class abstractions, high-level sort of code to interact with low-level devices. So if you want to connect to a motor controller or an air quality sensor or whatever you want, you can do that in a very small amount of code. You can do it quite quickly and rapidly. And you can do testing really easily as well, which is nice. So in general, it's kind of optimized for productivity. It allows for that much faster iterations rather than having to go through the setting up your compiler tool chain, trying stuff out, compiling it, deploying it. Typically it doesn't work. So you got to make a change, compile it, deploy it again, find out, and you kind of iterate toward a solution. Whereas in MicroPython, typically you'll just try it at the REPL. You'll know exactly if it works or not, and then you write your code. This last point I wanted to sort of belabor a little bit, because something I found having done a lot more of it lately is that I find that the language really gets out of the way. And so when I'm coding in C or C++, I spend a lot of time thinking about the implementation of how to make it elegant, how to make it use less memory, and how to write it really tight. And I'm thinking about how to do it, the mechanics of it. Whereas when I'm in a high-level language like Python, I spend much more time thinking about what's the problem I'm trying to solve and solving it. And so for me, it's a huge point. It's really not obvious when you sort of are comparing some of the benefits. It does come at a cost. The main one here really is memory fragmentation. So some of these devices, as I said, have very little amounts of memory. You've got to keep an eye on that and make sure you're not abusing the garbage collector. And there's different ways you can do that. We've got tools in place to help with that. But fragmentation is a real problem. If you're churning through a lot of objects and you're not aware of how that's happening, you'll quickly run out of memory. Performance is another issue that you need to be aware of. It's not really a bottleneck. Because although Python's and MicroPython is the same, it's much slower if you're spending time in the Python space. a lot of these things, like if we're communicating over SPI or I2C, or all of that's actually happening down in the C space. So it's actually happening really rapidly. You just got to jump that Python to C boundary. And there's also a way where you can create your own C modules and expose them into the Python space as well. So performance is never a bottleneck. You just need to be aware that if you're spending a lot of time up in the MicroPython space, you can be paying a bit of a penalty. Power use is another one, like for super low battery uses, where some of these devices are used. It may not be the best place, just because starting the interpreter from low power does take cycles. That said, you've got all access to the regular things to drive these things into their low power modes, so it's not that bad. Here's just a quick picture I posted on Twitter a little while ago about some of the devices we've got that run MicroPython. I'm running low on time, so I won't go into detail much here, but you'll see there's watches now. There's a bunch of devices with displays on it. A whole bunch of these have either Bluetooth or Wi-Fi, so they're easy to connect. A bunch of them have cameras nowadays. OpenMV here actually implements a lot of the OpenCV protocols, so this can do a lot of image recognition kind of things. We've got e-ink devices, little game devices. There's all sorts of things here. FPGAs, an FPGA that fits inside your USB port. Lots of things run MicroPython these days. And I'll make this the last slide. Just quickly, a couple of projects, just to, like, these are pure hobbyist projects that I threw together really quickly. A microcontroller with Wi-Fi to go and connect to PTV and get the time for the next 2 trains on my network. So one train's in 12 minutes, the next one's in 26 minutes. Now, this is something that took like an hour and a half to put together. And my nephew loves it. He looks at it and goes, "Oh, quick, we got to run. It's, it's 6 minutes. We're going to have to really get our skates on." And underneath my house, I had this space where I store a lot of stuff. It's long, low, and dark, perfect for an LED strip controller. And now it's being lit by a MicroPython powered device, which allows me to control it remotely. So I can check if I've left it on. It has a sensor to detect when I'm in there and just turn on. And I can also turn the brightness of the LEDs higher or lower. There's those links again. And I think that's all I got for you.
Fantastic. Thanks for that, Matt. It's interesting you commented at the start that we're that a lot of us are web developers, but so many of us also at least dabble in this sort of stuff. And I think that is totally what the future is. So it's really interesting to see another option there, because I myself have, played around with the C embedded code where you've got to do, like you said, you've got to change it, upload it, test it, change it, upload it, test it. So it's really exciting to see the options to speed that cycle up.
Yeah, it's really fun. I see other people have mentioned TinyGo, which is another. There's a couple of languages sort of starting to play in this space. I'd say MicroPython is probably the most mature of them at the moment. But TinyGo is great too. The developers there are great. So
fantastic. Excellent. Well, personally, my Zoom is starting to fall over again. I think a few of us are having some fun issues tonight. So I'm going to take this 10-minute break as an opportunity to restart my computer and hope it comes back. If anybody has any questions for Matt before we go for a break, just shout out now, or forever hold your peace at least till the end of the other talks.
People can reach out to me anytime through Twitter, email, whatever. I'll make sure I share all this, and you can reach out whenever.
Excellent. Fantastic. All right.